So today we are going to learn about JavaScript event loop and call stack and how JavaScript handles a synchronous operation. Let's get started. What JS can do, since we all know JavaScript is a single threaded language, means JS can only execute one operation at a time. So let's try to mimic it. So let's take an example of a chef with a single burner. Here we have the chef. This is our chef. This is our single burner, and here we have food order list, as you can see, and the list will be have multiple food and they can take different times. What do you think, how the chef can handle all the food items in a efficient way? So suppose the chef here is our JavaScript and the single burner here is JavaScript runtime, and here we have our food order list, which we can think of as a code. So now let's move to the next slide here. So how to solve this single burner issue? Maybe we can add more burner, but we can't do, as we know JavaScript is single threaded, it can only perform one operation at a time. Or maybe we can use some helper who can delegate some future tasks like cutting vegetables or making dough or marinating chicken, etc. So let's add. So as we have added helper to our stack here we have our helper right here. So what we can think of here is the chef can give some task to the helper, okay, and the helper will process those tasks, and after some time it will get back to the burner. Now in real world, the burner will be the helper will be our web APIs, we use set timeouts, ajax request, API calls, etc. But still there are many cases when the burner is already full and helpers may be sending cooking materials. So how do we handle that? So we need someone to manage the burner and the helper, and we name it our burner manager. Now adding the burner manager to our setup here. So here we can see we have this burner manager, and it's checking the burner, the single burner we have here, and if it sees the burner is empty, it takes the helper task or the food items, etc., and it gets back to the burner. Okay, so what actually the burner manager will be? So here we can see burner manager is taking some tasks from the helpers and taking some codes also, and checking if the burner is free, our single burner here, it send the task to the burner. Okay, so in real world it will be the event loop basically. So it checks when the single burner is empty, which means our call stack basically. Okay, now you might be thinking, even the burner manager manages and send task to that single burner, right? The burner at any point may get multiple tasks, right? But burner can execute only one task at a time. So how burner keeps track, basically how burner keeps track of the task and make sure it's not missed. Okay, so the burner has special qualities. The burner can keep a list of tasks and follows a stack for execution, means the last task executed first. So basically the burner has some special qualities. It's like a call, it's like a stack here. So the last one which is on the stack, it gets executed first, and then it proceeds subsequently. Okay, so this is what the call stack here means, keeps track of which task to be executed. Now similarly you might be thinking, then how the burner manager keeps a track of tasks from helpers and JavaScript code? So well, it does that with queue, which follow the order first in and first out. We'll look at this in a second. So let's get to our next slide here. So in chef terms, there can be some low priority tasks, maybe collecting extra tutti frutti for garnishing, similar stuff. But there are some high priority tasks as well. Maybe getting rice soaked in water for 30 minutes, or maybe boiling our potatoes. For example, we have two queue. One is a less priority queue and one is a high priority queue, which in JavaScript terms we call macro task queue and micro task queue. So basically what happens is the high priority tasks are there in the micro task queue and the low priority tasks are there in the macro task queue. There is a very short list of which task goes in which queue. You can take a deep read for that. Okay, so here you can see the task one is gone to the call stack, right? And when the high priority queue, which is the micro task queue, it's empty, then start taking tasks from the less priority queue or the micro task queue, right? So this is now our chef's world here. So this is our chef, we have our helper, we have a burner manager, we have a queue for managing task for burner manager, we have our food order list, and here we have our single burner. Okay, so now you can see the burner can the single burner can still manage lots of order coming at any time, and it is processing that eventually efficiently using things like burner manager and helper and the queue setup here. So now what is the equivalent in our JavaScript land? So let's move to our next slide here. Here you can see the helpers are basically web API, which offers things like set timeout, set interval, making Ajax calls, etc. Then the burner manager is basically the event loop, which like checks when the call stack is empty and manages the task. And then we have a callback queue basically, and it consists of two queue, the macro task queue and the micro task queue. In the callback queue, you can think of it as a waiting area for the task to being executed based on their priority. Here we have our JS code, and the single burner here is basically the call stack. As you can see, like this is actual the setup. These are all the components in how the JavaScript execute our code and handle asynchronous events. So let's know more about each. Okay, so first we have here our call stack. The call stack is a data structure that tracks function execution in JavaScript. It follows the last in first out order. As we can see, the stack of plate, for example, the one at the top will be taken out first. The function are pushed to the stack for execution and popped out when execution finishes. Yeah, that's very obvious. If a function will take too long, it will block everything. So as you know, like if someone like executes something and it's taking very long, so the call stack will be blocked and no any further task will be popped out. Now let's move to the next thing. Then we have web API. So web API is like browser provided tools that handle async tasks like timers, Ajax and DOM events. So you know, like JavaScript doesn't have feature of set timeout or set interval. It comes with a web API. It offloads like heavy or delayed tasks from the call stack. Okay, so it's like basically a helper, which we have seen in our previous chef example. Example like set timeout, fetch, add event listener and all that. Web API are external to JavaScript and operate in the background. That's very obvious too. So now we have event loop. So it's an infinite loop. It checks if call stack is empty, move task from callback queue, which is like consists of micro task and micro task queue, to call stack when the call stack is clear. It's single threaded in nature and make JX non-blocking by handling async task. And it checks like if the call stack is empty, it like push the task to the call stack. Okay, now we have our fourth element. We have our callback queue. So callback queue is basically a waiting area for callbacks async task after web API complete. So basically, like if you send something to the helpers like do helper, which is like web API, it handles some tasks like cutting fruits and all that, but now it's like goes to the callback queue, and then when the event loop sees the call stack is empty, it take the task from the callback queue, right, and push it to the call stack. It ensures that the tasks are handled sequentially, but only when call stack is free. Okay, that's very obvious too. So that's it. You can learn more about things. I'll put some links in the description that will be like more detailed reading, but this is like kind of gist you can think of with a very practical example on how JavaScript handles asynchronous operation and all the tasks. So thanks for watching. Please like, share and subscribe if you find it useful. Thank you.